Hey, the video you're about to watch is in two separate parts. The first is a quick little vlog showing the end result of the second part, which is how to fully build a budget drone. This entire drone, every single part is available in the description below, and if you purchase these parts, it supports the channel. But we're going to take you through every single exact, detailed, minute step from start to finish to build your own FPV drone. I'm releasing this hour-long tutorial video for free, and if you found it useful and you're in a place where you can, please consider signing up to be a Patreon or a YouTube member. It would really help us financially continue to make content like this. Appreciate that. Sorry, I gotta get that ask in there. Beyond all of this, this is designed to be a budget drone. You should be able to pick up all the parts for the drone for about 210 bucks. The controller is only 80 or 90, and the goggles are 100 bucks. All together, you're in for less than $500, and that's going to get you in the air with your first home-built FPV drone. So without further rigmarole, check out this vlog to see the end result, to see what the drone flies like and what our reactions are to it for the first time. And then stick around to learn how to build the entire drone. And finally, for one lucky winner, we're going to give away the controller, the goggles, and the drone, complete with dirt from test flying it. Sorry about that. But hey, it's tuned and it's ready. And yeah, so we're gonna give this whole setup away. I bought it all to give it away. This wasn't even sent to me. I'm just like, we're getting this out. Somebody's gonna get in the air as a result of it. I'm going to leave instructions on how to enter for after the next segment of this video, which is the vlog segment. Just whip it out and wipe. Clap sync. All right, so we've finished up building up our super cheap drone, and then put on a camera that's more expensive than just the drone by itself. And we're gonna freestyle it. So like, all I have done is hover tested this so far. I haven't even flown it around my house or anything like that. This is gonna be the first place. So I've got my GoPro on there. I've got 4K 30, I think Hypersmooth is on. And yeah, we're just gonna do some freestyle here in the woods with a budget drone. Really excited to just see what this is like. I wanna prove that you don't need like top of the line equipment to crush it. Now, there's obviously benefits of having the like nicer stuff, but I'm using an $80 controller, which is a pretty good deal, and $100 goggles, and we're gonna send it for some good freestyle. I might crash a bit because these are 16:9, and I usually use 4:3, and my camera is 4:3, so it's a little bit stretched, a little bit of getting used to it, but I think we can do some cool stuff. GoPro's rolling, drone's on. I don't think I've done any tuning on this yet, so we may need to adjust some PIDs, but I think for the most part we're gonna be good. I'm borrowing this. First flight, I'm excited.
I'm gonna go stand out there.
Oh my gosh, this thing flies great. Dude, do you hear that thing? Oh no! Hold on, let me try the turtle mode. She good? Like, I'm a little awkward on the sticks because of the aspect ratio, but honestly, this thing flies great. Okay, so my expectations were that it was going to be fine and tolerable, but this thing, I think probably because of the weight, mostly like because it's like 4S with some light motors and stuff like that, it's snappy as hell. Like, listen to that. Here, I'm going to go close to us. I'm just going to do a snap roll. I don't hear any bounce back or anything. I mean, I'm hitting gaps. No problem. I'm having a hard time seeing the scraggle branches with the analog because it's just been a minute. But like, this is freaking phenomenal. I wish I was giving you a more exciting flight. I might switch to my HDOs just to try to send it a little bit better. But like, honestly, this is $180 worth of peripherals and a $200 drone. What? Do a knife edge here. Oh! $200! I regularly build like $400 and something drones. And this thing is just chooching. What in the world? Okay, yeah, so if you want to get into the hobby of FPV and you want to keep it under $500, Recons, 5-inch drone for 200 bucks, X-Lite, done.
About to fly the budget quad. Been a minute since I flew anything other than my own. After watching you fly it, I'm pretty excited.
You're good to launch, just go forward a little bit.
Are these your freestyle?
Yeah, my new ones. 800, 800, and then like 500 on yaw.
Oh wow, that yaw is loose. Or
Slower?
yes.
Yeah.
Can you hit the fan button on my goggles?
Yes.
Oh, you're a good friend. Oh god.
Jeez. I punched your antenna. Did it go?
I think so, yeah.
Okay.
Yeah, dude, that thing flies nice. It's like, I wonder how much Betaflight has to do with this thing flying so well. I mean, the hardware itself makes it work. I mean, it's definitely not fast, but it's fast enough.
I mean, if you're just trying to freestyle, though.
Oh, for freestyle, yeah.
Get the gap, get the gap. Oh, God!
I mean, pretty impressed. It's a freestyle quad. And yeah, no issues. It's still got plenty of power. I wouldn't be able to tell it was a cheap build if I was flying another comparable 4S drone.
Give it some range. See if you can kind of punch through over to, like, I know there's a bridge over there. Like, see if how the FR Sky does.
Did you fly over the water while we do it?
Yeah, I'm gonna turn your antenna up. You good there?
Cool. I'm out on that bridge. I don't see RSSI anywhere.
Just stay over stuff where it's okay if it drops.
It's doing fine. I mean, I'm not far away, but there's stuff between us. Video is actually all right, dude. Oh, now it's getting hairy. Okay. Oh, shit. Okay. Oh, yeah, I'm setting that down.
Well, let's walk back and see how far
Yeah,
it
no,
is.
I mean, it did as well as I expected it to, I would say. I mean, it's a decent little freestyle quad for like a $220 drone itself. I can't argue at all. Like, if I was just getting into the hobby, that would fly amazing.
If you hadn't been told how much that was, would you have been able to say that it was a $200 drone?
No. Yeah, no. I would have known it was a 4S for sure, but like, I wouldn't have been able to guess it was that cheap by far. Yeah. There's a lot of stuff between us.
We were all the way over there. You can't even see our car anymore. And the drone is all the way over there.
So I mean, that did pretty good. The issue was video. I still had range on the FR Sky, but video just got too low. But we were also punching behind a bunch of different stuff, so. I mean, any other drone would have the same issue.
It's like you landed it. Get it out over the water. Let's see it. Don't crash. But yeah, I'm still stuck on the fact that that's a freaking $200 drone. Like, budget parts, like as budgety as you can get. And it's like, it sounds like any other drone. It flies like any other drone. It was nice and snappy. I just heard a tree branch. Hopefully he didn't put it in the water. Where is it? Are we good? Okay, there it is. Thank goodness. I've only gotten to fly it once.
Dude, I'm super impressed. I can't lie. Now I kind of feel bad because I always buy super nice things and I might not have needed to.
We're going for some HDO runs on the budget build. So I flew it with the Recons. The Recons are not set up for me. They're totally fine goggles, but my HDOs are like my goggles. So I'm hoping to get a little bit better of a run. Whatever looks good, dog. Oh yeah, this is much more my jam. Ooh, scraggle. That was lucky. Yeah, baby. Dude, honestly, this thing is juicy. I think it feels good. Yeah, absolutely. Woo! Oh, I just barely clipped the ground. So, I mean, in terms of like a freaking budget build, like I am not complaining about that at all. Like I haven't smiled this much flying in so long, because it's just like, yeah, it just go fly. And if I break something, like the most expensive thing on this, other than the GoPro, I should say, is, oh, well, it was other than the GoPro. Apparently I dinged it up again. The most expensive thing on this, other than that GoPro, was the flight controller, which is $30. And like, those are hard to break. Like the flight controller is more expensive than the whole frame itself. And then, you know, like if I break a motor, oh, $10. I mean, like, yeah, $10 is $10, but like compared to like a $30 motor that I usually fly, for that amount of like smiles per mile kind of stuff like that was great. Huh. Anyway, all of the parts, all of the things that we used for this are in the link in the description. The rest of this video is exactly how to make this drone. So go ahead and check it out, and you could be flying this same thing just as hard as this, and it's gonna keep up with you. So get out there, try it out. So thanks for watching this whole video. Please consider using the links in the description to support the channel and more things like this, and stay flying. Okay, so in order to win the competition, in order to win the giveaway of this entire drone kit, I want you to do 3 things. You're gonna make sure you're subscribed to this channel, obvious. You're going to make a comment in the description below, and that comment is going to include the word budget. But don't make it too obvious. Make sure that anybody that's just trying to leave a comment isn't getting there. But it has to include the word budget. And I want you to tell me how this drone would help you in your FPV journey. So subscribe, use the word budget, and leave a comment telling me how this would help you in your FPV journey. Thanks very much, guys. Enjoy the build. All right, let's start with an overview of the parts that we're using here. All of this was purchased from Get FPV, so all of the links down below you can use to get exactly these components so that you know exactly how to put everything together. Now again, this is a budget build, so I kind of put some effort into finding cheaper components, things, not necessarily things that I would totally recommend, but you know, if we're trying to save a couple bucks, you know, this is the way that we're gonna go. So starting across the top here, these are our motors. These are 2205, 2250 kV brushless motors. They're most built for the 4S range of voltage. That's 2250. They're probably made by Brother Hobby, which is a very respected drone motor brand. But you can see that, you know, they're just nice, solid little motors made by Xylo, which is Get FPV's like side brand. Nothing very special about them, but they should be really solid. They're a well-respected brand that are, you know, I think these are $10 each, so nice and cheap. It comes with all the components that you need. Just quickly about motors, there's 2 numbers on any given motor. You have 2205, which is the width and height of the stator, and then you have 2250 kV. kV is rotations per volt per minute, basically. If you look at the 22, that's the width along the bottom of the stator, and then the height is 2205, which is the height of this bell part, basically. Small correction, the bell is not where you measure the stator. The stator is the actual set of magnets that's underneath the bell, and that's where you actually do the measurement of the stator size. It's just easier to reference it in terms of the bell, which you can actually see. So the kV is rotations per volt per minute. So you basically just multiply this times your battery voltage, and then you find out what the RPM is going to be. Any given motor RPM should be roughly 40,000 RPM or so. So you multiply this times 16.8. That gives you, I think in this case, it'd probably be like 38,000 or so. I'd have to do the math on that, but so this would be a great motor for 4S. Moving over to the side here, we've got our ESCs. These are also the Xylo brand, which is, again, just Get FPV's budget brand. They're just rebadged, so they're going to be fine. You know, they're 40 amp ESCs, so you shouldn't have any problems with these burning out. 2 to 4S, and then their BL Heli S, which is, you could get BL Heli 32, which is newer than this, but again, budget brand. We've got our receiver, which is a FR Sky RXSR. This one's set up for the access mode. Not a lot to say here. It comes with all the cables you need to plug it in, and then we'll solder it directly to our flight controller. We have a power distribution board. This is by Maytech. It's got a 12 volt and a 5 volt regulator, perfectly suited for 5S. And when we're building with individual ESCs like this, instead of 4-in-1 ESCs, we need to have all these pads available. A note about ESCs, they have different voltage ratings. So this one's 2 to 4S. They have different amperage ratings. This is 40 amps, and that's the amount of power that can be pushed through this into the motors. And then they have BL-Heli-S, which is the firmware type. So you have options that are Simon K, BL-Heli-S, BL-Heli-32, and then there's others out there. But those are kind of the important things to note about ESCs. And then you can also get them as individual ESCs like this, where you have all 4 of them, or you can get them as 4-in-1 ESCs, which have all 4 ESCs built into one board that looks kind of like this. Next up, we've got our FPV camera. This is a Fox Seer Razor. I believe it costs $20. It's a mini camera that's going to fit on our frame, which is we're coming up to. Nothing super special about this either, just a nice little FPV camera, nice and durable, nice and sturdy. Big lens, which is actually really nice if you ever end up flying in inclement weather or anything like that. For the flight controller, we're using the Xylo Stax flight controller. The Xylo Stax flight controller is just a nice little F4 flight controller with a lot of different pads, and it's designed to work with their Stax system, so you can actually buy a 4-in-1 that will link straight into this, but it also has outputs for your camera, your receiver, all 4 motors. Whether or not you're using the 4-in-1 or not, you can solder them straight on down here. Tons of options for that, and it's I believe $30, which is pretty good for a flight controller. This is probably one of the places where we probably could have saved some more money, but this was the best option, best dollar per value option. You could get like an F3 chip or an F1 chip. Tons of different things that we could say about flight controllers, but for the most part, know that there's firmware for flight controllers, and that could be Betaflight, Raceflight, Flight 1, KISS, Emu Flight, iNav. There's a ton of different options. Not all flight controllers support all firmware, and so in our case, we're going to be using Betaflight, and we're probably going to be using Betaflight version 4.2. So just a lot of information, kind of throwing it all at you at the same time, and just don't be overwhelmed. I'm just kind of throwing enough at you to be able to Google stuff. For VTX, we're using the nameless RC Nano 400 VTX. Takes a 5 volt input, has a pit switch, 25, 100, 200, and 400 milliwatts. Just a nice, very cheap VTX. I believe they retail for like $13 or $14, and so that would be a nice budget option for this build. But you'll also get 400 milliwatts. And then finally, our frame here is the TBS Source 1. It's a very cheap frame. I think it's like $22 or $23, but it actually uses pretty high quality carbon fiber. Like there's no bend in this, and it's really well respected through the industry. It's kind of just being a brand that's focused on accessibility for everybody to be able to get up in the air and fly. It's not gatekeeping at all. It's just a nice, cheap and easy to use frame, and so that's what we got. And then the last little bits and bobs that I bought are like a hardware kit with some little organizers with different kinds of screws and all that sort of stuff, which is going to help us build the stack together later. So, yep, let's dive into the build. The place I start is with the frame. We've got our main plate, bottom plate, and arms, and we're going to start with those and get everything kind of assembled to the point where we can start to work on the frame. This main plate has these inset screws. You can see that they're wider on one end than on the other. And you want to make sure that the wider end is on top, because the screw is going to start pulling down through the hole, and that hole needs to be pulling on the carbon rather than accidentally pulling out the threaded part like that. So just make sure that these are up top. When you're assembling the bottom part of the frame, just make sure that the plate holes match up like this, and then you're going to use the long screws in the middle and the shorter screws on the outside. And the long screws we're going to use to mount your flight controller equipment on top of, so you got to make sure that it fits all the way through. Okay, when I'm assembling the frame, I'm going to use the small screws on the outer arms, and then I'm actually going to take these longer M3x20 socket heads from inside of my hardware kit, and we're going to use those as the central standoffs, and I'll show you why in a minute. But this is how we're going to mount up our entire flight controller. So we want these longer screws in here instead of the shorter ones that come with the frame. Now you could use the ones that come with the frame, but I think that this is going to be a better, more durable solution. And go ahead and cinch everything down when you're done. Now our bottom piece on the stack is going to be the flight controller. So we want to take some of these M3 nylon nuts and thread them all the way down to the bottom of our main stack bolts. These don't have to be super tight, they're just acting as a spacer between your power distribution board and the conductive carbon fiber plate on the bottom of your drone here. And then again, paying attention to what's the front and what's the back. The front being this side with these little marks. We're putting the camera of the flight controller, or of the power distribution board, forward. You can see cam plus, VTX plus minus there, because our camera is going to be up here. And then on the back we have some jumpers. And then our battery lead is actually going to come out the side, which is something I want to do for this particular frame. I want the battery lead to come out this way. And then we can take some of these little spacers here that are just going to slide down over top, and they're going to hold the power distribution board, or they're not going to hold the power distribution board, but they're going to give you a separation between the power distribution board and the flight controller, which will then eventually sit down over top of all this like so. And you can see that there's a nice spacing between the flight controller and the power distribution board. But we're not ready for that step yet. I'm just going to put these spacers back so I don't misplace them. Okay, the next place I like to go is the speed controllers. And those are each going to stick out on the arms like this. You want to leave a little bit of room for your motors, so we're going to kind of cheat them in a little bit as much as we can. So this is roughly where you're going to want it to end up, with this capacitor kind of on the inside, and then the pads for the motor coming out to the outside. But you can see that there's copper traces on the bottom of this, so we need to kind of protect that against the carbon fiber. So for that, I like to use a little bit of double-sided tape, which will also help hold the ESC in place. So I'm going to take one piece, and on the underside of this ESC, put it like that. Trim it back a little bit. And I'm going to put one underneath the capacitor to help hold it in place. And then place the whole thing like so. And then use a zip tie or some electrical tape to hold it all in place. And before we go on, what I'm going to go ahead and do is tin the power distribution board. And all tinning is making sure that the there's a coating of solder already on the power distribution board. And to do that, we're going to turn our soldering iron on. We're just going to add heat to the solder and the pad at the same time. And it should make a nice, round, silvery bubble on the pad, like so. And now for our ESC, you can see that there's a positive and a negative lead there. A positive here, negative there. What we're going to do is we're going to trim the wire on this ESC as short as possible without going too short. So something like that. And then our positive, just about the same length. Set the extra wire aside. And then comes the probably trickiest part of this, is you want to trim back some of the wire. So just kind of cut into the silicone without cutting the whole thing off. And then just expose a piece of the wire like that, just a little bit. And then tin both of the pieces of wire that you just exposed. Again, all that's doing is just getting the end of the wire wet with solder so that you'll be able to connect it then to the PTB. Now if we look at this up close, you can see that the two wires of the ESC are now wired into the power distribution board, into their respective positive and negative components. We still have this cable hanging off, which we don't need to worry about yet. And now we're ready to move down to the motor tabs. So we're first going to tin those up. Now we're ready for our first motor. The motors came with motor screws, and you just want to make sure that the wires go on facing down towards the bottom of the frame. Typically I just leave the first one a little bit loose so that you can kind of turn the motor around like this and make sure that you get the pad or the actual screw holes lined up, and then cinch each one down. Get it nice and tight. Take your propeller screw or nut and put it on now so that you don't lose it. And then we're going to solder the wires of the motor directly to the ESC. Doesn't matter what order, we'll fix that all later. So just cut them to length and put them onto each pad just in a row in the cleanest way you can. Be sure to tin them first. And then solder them right to the pads like that. And voila, your first motor is fully connected and ready to go. Go ahead and take the motor and spin it. If it freewheels a little bit, then you're good. But if you accidentally short out the motor, meaning you have these like solder pads bridged or something, it will not spin freely, and you'll know that you need to clean up some of that wiring. But for now, that's looking really good, so let's move on to each of the rest of the ESCs. You just have to do the same thing exactly 4 times, and it'll all come together real quick. Through the magic of editing, we are all done wiring up each of our speed controllers and motors. It really only took me about 20 minutes worth of time. I do have a lot of practice with this, but it's not too bad. So the next thing that we need to do is think about our flight controller. We have to wire each of our speed controllers to the flight controller, and in order to do that, we need to make sure that we have access to all of the pads. Now, for this flight controller, we do not have any pads on the top for each of the motors. They're all included in this plug, which could be used. We have the cables that we need for it here, but then we have to connect all of the wires to each wire individually, which can definitely be a pain in the butt. So instead, on the bottom, there are individual pads for each motor. You can see S1, 2, 3, 4. So before we place this flight controller down and face down, we need to make sure that we have those pads wired up. Now, each of these ESCs have a ground and a signal wire. You can see the black and the white. In my experience, and this is only in my experience, so it may not be the case for everybody, I have not needed the ground wire. So what I'm going to do is actually cut this ground wire real short. If I was really smart, I would actually desolder it and stuff. And then just cut enough of this signal wire to be left alive to be able to connect it to the flight controller. Now, some people might say that the ground is necessary. I mean, I've built 300, 400 drones and never had a problem with just lopping off this signal wire or this ground wire on individual ESCs, with some exceptions, but not on these components. And now the next thing we want to do is make sure that these are just long enough to reach these pads, but not so long that we have a lot of extra wire. So usually what I'll do is kind of just judge it by crossing it most of the way across the PDB, because I know that will reach all the way down and underneath the flight controller, and then it will give us a little extra length to be able to take the flight controller on and off. And then we'll just strip each of these wires and tin them and have them ready to go. So these will probably be a little bit too long, so it could be cleaner, but I'd rather have a little bit too long than too short and become more of a pain in the butt and just make it easy to build and easy to work on. Tin 1, tin 2, tin 3, tin 4. Then we'll take the flight controller and tin each of the pads. 1, 2, 3, 4, and now we're ready to wire those up. But before we do, I want to take a look at our power distribution board. So both our camera and our VTX can run on 5-volt battery. And for the purposes of this, I'm going to go ahead and run both of them off the flight controller, because that's going to make wiring it a whole lot simpler, because the flight controller has a bunch of extra 5-volt pads and has a big enough regulator to power the camera, the VTX, and the receiver, as well as the flight controller off of it. So all we have to do is have the ESC send full voltage to the flight controller, because this takes 3 to 6S voltage, and we do that by wiring it into the VBAT pad here on the bottom, as well as the ground. So we need to tin up 2 more pads on the bottom. So right here and right here. And then we need 2 wires for the ground and the VBAT. And lucky for us, we just cut off a bunch of wires from our ESCs. We can use those to put these on. So I'm going to tin a white wire for my VBAT, and a black wire for our ground. And now we're going to put each of our ESCs on. So remember, this is where the front is, and on the way that Betaflight does our motor order is that the back right is this one is 1, front right 2, back left 3, front left 4. So we need to make sure that this goes to 1, this goes to 2, this goes to 3, this goes to 4. So we'll just set this down. So 1 to 1, here's 2. It's going to be a little bit tricky to get this all sorted out. Just have patience. 2 to 2, now 3. Sorry, that's 4 actually. Now 3, now 4. Okay, so now the flight controller has 1, 2, 3, 4 wires, starting 1, 2, 3, 4, and then it has ground and and VBAT to connect the power to the flight controller. So we'll strip off the ground and VBAT wires here, tin them, and then we're going to wire them into the positive and negative straight on the battery on the power distribution board. All right, let's review with a little close-up here. So we've got 1, 2, 3, 4 motors side to side, and then underneath these motor wires you've got VBAT and ground. The VBAT and ground connect straight to the extra pad here for positive and negative on the power distribution board, and then each motor 1, 2, 3, 4 connect to the flight controller. So now we're going to flip the flight controller over and put it on. So we've got to put our spacers back on first. So got one. There's 2 different sizes in here. I'm using the bigger ones. And on this flight controller, you can see there's a tiny little arrow right here that's pointing forward for the direction that the flight controller is supposed to point. But it doesn't matter which way it goes, because if you get it wrong, you can always flip it around in the software later. But before we do that, we need to put our XT60 on. We're going to take this off and move it off to the side. So on the side of the VTX, or the PDB here, you've got a bat plus a negative, and that's where our XT60 pigtail is going to go. The right length is hard to say. What I like to do with my own builds is to have it come up the side and then kind of turn over like this. So that length is probably, 3-4 inches of extra cable. So I'm going to say something like that. Cut off the wires, and now we're going to tin these up, and then we'll solder it right on. Now this is going to be your hardest solder joint because it's such a big joint, so just take your time. I'm letting this touch the pad to the side of it because they're both ground, and sometimes you just have to add a little bit more solder in to make it all come together. But it will get the job done. Now the same with the positive one. Add a little extra here. And again, both those pads are the same pad, so it really doesn't matter if they're touching or not, as long as you're not crossing the positive and negative. Voila. So now we have our XT60 on, we have our flight controller standoffs ready, so let's go ahead and put this flight controller down on top. Just be careful that you don't pinch any of the wires that you have running underneath. Just make sure they're all free of the standoffs and stuff that we've been putting in there. And this is staying in place pretty well, but you definitely want to put some extra nylon nuts over top. Make sure the flight controller stays in place. And you don't want it very tight, you just want it enough that it's going to stay in place. You want to have it be able to kind of move around just a little bit with the rubber bobbins that are on there. You can see that there's some rubber on the flight controller that you want it to be able to kind of move a little bit independent of that so that anti-vibration plays its role. Unfortunately, for the purposes of this video, I'm going to skip the receiver. A lot of different people like to use different things. In this case, we should have used an Archer receiver. I'll link a description to Joshua Bardwell's website that shows how to use that particular receiver for a build just like this. But I didn't have it with me. I used an older one and I had to flash a whole bunch of firmware, and that's not the kind of stuff that I want to have you guys doing. I think that overcomplicated the issue. So enjoy, you feel free to jump over to Joshua Bardwell's, check out the receiver for this section, and then pop back over here and I'll show you how to get everything else set up in Betaflight. Next up is going to be our VTX, and this is probably honestly going to be the hardest part of the build. So these are all the parts it comes with, and it's got some nice tiny little wires and a UFL connector for our antenna, and for the purposes of this build, because again it's a budget build, we're just using that antenna. Okay, so for the wiring, the corner closest to the UFL It's 5 volt, then ground, then RX, then video, where RX is going to be our smart audio. Smart audio is the communication protocol by which the flight controller can communicate to any given video transmitter. There's a few different types of smart audio protocols, the two major ones of which are smart audio, which is TBS or Team Black Sheep's protocol, and the TRAMP protocol, which is made by Immersion RC. In the case of this video transmitter, it uses the TRAMP protocol. So we've got to figure out how to get in here and hit these little pads without accidentally getting two pads at the same time. And that is not going to be an easy task, even for experienced solderers. Just take your time, make sure you get it right. So I might alternate. I'll do one on top and then one on the bottom, just to make it a little easier on myself. Because they're the same pads, just I'm giving myself a little bit more space between each of the joints. Okay, got it. Flip it back over. Then it said RX, so we'll use white for RX. Try to get just that pad. That's good. Flip it back over. Give ourselves more room. Keep your soldering iron tip nice and clean. Tin your wires. And get each of those pads. Oof! That was not easy. But you can see each wire is hooked on there, separate and clean. And there's no pads bridging. Just give them each a little bit of a tug. Make sure that they're pretty well connected. You don't have to use a ton of force, but just enough to know that they're not going to pop off randomly. And that's feeling pretty good. Now, I was thinking about this earlier, and I really want the VTX to come out the back of the bird. But I knew that these pads were so small, so I used these short wires, and I'm intending on purpose to kind of strip these back and make them a little bit longer. So I'm going to go ahead and just strip these off, and we're going to go ahead and tin them up, strip these off, and then we're going to really carefully join each of these wires together. Just a little bit of heat should do it. Doesn't matter if it's really messy or not, it'll hold. So all we've really done is made these wires longer. And again, I could, see, that's what I was worried about. Kind of came off that pad there. That 5 volts, that first pad. I used these smaller wires because it would be easier to definitely be able to hit the pads with those small wires and then extend them later, because this is much easier to do than try to hit these with really small pads. So let's put some heat shrink on this so that we have this nice long cable for our VTX. Okay, and when you're done, this is what this little squid should look like. Got each of those things tinned up and connected. And we got some nice long wires, so we can hook this all in the right way. I'm going to use this extra little bit of heat shrink that came with the VTX to put around my receiver, just to help protect it. And I'm just going to go ahead and VHB it right down to the bottom of the frame, so it can't go anywhere. And then the same thing with the VTX. We're going to just put it right next to it. Then I'm going to take these cables and run them underneath the flight controller, because all of the pads that we need for it are right here at the front. So just barely lift this up. Grab all these underneath. And then drop the flight controller back in place. Careful not to pinch anything. And then we have across the front of this flight controller pads we need. Got VTX, Smart Audio, which is the receiver, power, and ground. Then we're also going to use camera, power, and ground. Since the power pad here on the flight controller actually gives VBAT, like a filtered full battery voltage, to the VTX, and this VTX is only a 5 volt VTX, we need to wire this power lead from the VTX to a 5 volt pad, which is really simple. We'll just run this 5 volt out the side to this 5 volt pad over here. So I'm just gonna carefully thread this wire through, grab it, flip it over, cut it, zip it back, tin the wire, tin the pad, fold this bad boy over. Hook it up. Okay, so now the 5 volts on. Now I just need to do the same with the rest of the wires from the VTX. Kind of just fold them all up like this to get the length right. Cut them just a little bit long. Get rid of the extra wires and strip, 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 and then tin, tin, tin. The video, tin the receiver, tin the ground. Now we'll fold these back over. First is ground. Second is smart audio. And third is VTX video. And boom. Now our VTX is wired in as well as our receiver. You've got VTX, RX, ground, and 5 volt. And finally, we will move on to the camera. For the camera, just got a simple cable with 3 plugs. Goes in there. Just check our length. Maybe something like that. Just a little extra so that there's some room. Strip it. And tin it. Then we've got ground, camera, and power. That'll do it for the camera. And actually that's all of our wiring. So now we can start buttoning up the rest of this whole thing. We'll go ahead and take the camera off of there for now. Grab our 2 camera plates, which are the side plates, and just dry fit this and make sure we know what we need to do here. So these are going to situate like so. The camera's going to go in here, but oh no, it's too wide for the camera. Luckily, these cameras come with this extra mounting plate, which you can stick in here, and now it's wide enough to fit between those two. So we'll first screw this plate on, using all of our extra screws that it comes with, which are an absurd amount, honestly. And then we're going to take each of our camera plates here and put the screw through the side, and I'm just going to go ahead and use the middle mount. There we go. And we can plug the camera in. Actually, I won't plug it in yet, just for a second. And just like that, camera's in place, right side up. We should be able to plug this in, no problem. Got plenty of room. But we need to put our standoffs in first, so let's go ahead and do that. So we've got a bunch of extra screws here left over, and all these standoffs. Now we can plug in the camera. I like to just twist up the camera lead a little bit. Slip it into those slots. Boom. And then top plate on. And just like that, fully built drone. I wanted to make a quick note about analog FPV antennas. In this video we used 2 linear antennas. Another word for them is whips. One is on the goggles, it's the long black pointy one, and then one is on the drone, it's the one that's connected via UFL to the transmitter. These are not the best kind of antennas, in my opinion, for flying. For example, we could use something like this. It's a matchstick antenna. I got a whole bunch of them here. Matchstick antenna that is a circular polarized antenna. This one happens to be right-hand circular polarized. Here's one that's left. They're really hard to tell the difference. But you should invest in some higher quality antennas, but because this was a budget build, I wanted to get you guys in the air for as little as possible. So sticking with those particular options is what's going to be better. Then you can start advancing to patch antennas. These are much higher quality, higher directional antennas that allow you to go further range as long as you're within a certain as long as you're heading out inside of the funnel that the antennas create. So there's a lot that could be learned about. There's a lot that could be left to learn about antennas and how different antennas can change different things for your builds. And I'm not going to go into them in super detail because it's not part of the budget aspect of this. We're sticking with what's the cheapest. But I wanted you to know that if you're interested in pursuing this further, you need to learn about antennas. And then the final real hardware piece is the battery mount, which is going to fit on just like this. So we'll take our 3M off the back. Oh no! Oh no. I've made a huge mistake. Turn around. See where the little screw nooks are. Place that on there, and that'll just help grab the battery in place. And then if you get a GoPro mount, you can put the battery like this. And if you get a GoPro mount, you can push it back a little bit because your center of gravity will change a little bit. So yeah, with all that, this drone is hardware ready. Just need a LiPo strap, which can just go around the outside of the frame like this. It'll hold your battery on place, and then you can plug it in through here. I usually do something like that. No big deal. So let's move over to software settings. Okay, so I've rebooted the flight controller into DFU mode, and all you have to do is, on the flight controller there's a little button. You just have to hold that button down while you plug in the flight controller. Not a big deal. The DFU in Betaflight just means that it's in bootloader mode. It means that we can flash new firmware. So we're going to go down to firmware flasher, wait for it to load, and we're going to scroll until we find Xylo F4. That's just the name of the firmware of this thing. And we're going to use the latest version of Betaflight, which is 4.2.5, full chip erase, and load firmware online. It thinks for a second, loads the firmware, and then you say flash firmware. It erases the entire board and then restarts from the beginning. And so now we just have to wait for it to do that bootloader process. Okay, programming was successful. Wait for it to reboot. The COM3 comes up, and now we should be able to connect. There are custom defaults for this board available. Normally a board will not work properly unless custom defaults are applied, so go ahead and apply custom defaults. I will also give you a dump that you can use. And then let's go ahead and test this. So look, using the drone, the camera being up front, the nose up there, back is back, left is left, right is right, front is good. So our flight controller is mounted the proper direction. That's a good important test to do before you jump into anything. Ports should be previously set up already. Your serial RX is UART1, and then we'll pull up the manual for this. Looking at the guide on the pin map here, we have video output, smart audio, VTX bat, VTX ground. So we've got to figure out which TX RX that is. Oh, there it is, TX5. So we need 5 to be VTX smart audio, save and reboot, I believe. Let's double check on our nameless RC VTX manual. So we have 5 volt ground RX video, that's all connected to TX5 Tramp smart audio protocol. So I was going to use TBS smart audio, but it's actually IRC Tramp. So we're just going to go ahead and change that to that, save and reboot, wait, come back in, close. Now we're going into configuration. So my goal is to have the motor direction reversed, and what that means is that the props are going to spin out away from the camera and then in towards the back. So I'm clicking this motor direction is reversed, but that's not the only step we have to do for motor direction. So hold on. I'm going to go ahead and leave this system configuration stuff all pretty normal. I'm going to leave this 8K, 8K, and for the now we'll leave the accelerometer, barometer, and magnetometer. We're going to turn off baro and magnet and leave accelerometer on. We're going to name the craft. I'll call it NERC budget. And we can ignore camera. We are not using that. Then we're using serial-based S-bus for receiver type. Down here in all of this, we can leave everything off except for air mode, OSD, and dynamic filter. Leave those on. Air mode is a setting that basically when you go to zero throttle, the drone doesn't fall out of the air. OSD is like the on-screen display, so it's all the settings that you see in your goggles, like your voltage, all that good stuff. And then dynamic filter helps make sure that the tune is nice and smooth. Everything else is other features that are not used as much in racing drones. I kind of like the D-Shot beacon configuration. So basically what happens is when your receiver is disconnected, meaning like maybe you fail-safed, you had an issue, your controller is off, each of your motors will start beeping for until you find the drone and unplug it, or until it gets connected again. And that could be really, really helpful if you lose the drone in grass, tall grass. We're using D-Shot. We'll go ahead and use 300 because I don't know exactly what these ESCs need. Motor stop we want to be off. Basically what happens when you have motor stop on is that when you arm the quad, the motors don't spin until you throttle up, and that's kind of a safety feature. ESC sensor we're not using. Bidirectional D-shot we're also not using. And minimum arming angle, set this to 180. Basically what that means is that at any rotation you'll be able to arm the drone, even if it's fully upside down. And that comes in handy when you're running the accelerometer on. So we'll go ahead and save and reboot. And then we'll go to PID tuning. I haven't tuned this drone yet. I will make a tune and kind of drop it in a little bit later. So here it is on screen. Hopefully it's fascinating. It's also going to be available in the description below. For now, all I'm going to do is put in some basic settings, like feed forward. I like to be at 150. Save that. And then I'm going to go over to rate profile settings and put in my rates, which are 0.8, 0.8, 0.8, 0.8, 0.8, 0.7. Save. Leave everything else the same. And then filter settings, we're just going to go ahead and turn this filter down a little bit. That's all. Receiver we're going to come back to because we have to set up our controller. And then modes, we're using an arm switch, which we're going to put on aux 1 at the top. We'll have an angle switch, which we'll have an angle and horizon, so we'll need ranges for those. And we'll have them be angle in the middle, horizon at the top on aux 2. And then we'll have a, where is it, flip over after crash on aux 3 all the way at the top. That's going to be our turtle mode situation. And the rest we can ignore. So we'll go ahead and save that. And now we'll go into the motors tab. So this is our first big piece of work that we have to do here. So with the motors, we don't necessarily know which direction each of them is turning right now. We just wired them up pretty much at random. So what we're going to do is we're going to plug in our battery without our props on. Our props are off right now. Click the I understand the risk, the propellers are removed, and slowly throttle this up. Okay, so now all of the motors are spinning. And we're just going to feel with our finger which way it's going. So this one is spinning this way. This motor is spinning the same direction, which is wrong. This motor is spinning that direction, which is wrong. And this motor is spinning this direction, which is good. So what we need to do is change around the directions of motors 2 and 3. And to do that, we're going to use a different program called BL Heli, which is available with a configurator in Google Chrome for BL Heli S, which these ESCs are. So we'll go ahead and click Read Setup, which is in the bottom right. You can't see underneath my face. I want to change this setting to 2 minutes, the beacon delay, and turn the beacon strength down a little bit. Then we're going to change ESC 2 to reverse and ESC 3 to reversed. And then we're going to take all of these things and move them to be from 1000 to 2000. You can use the arrow keys to be more precise. And right setup. So now what we've done is we've changed some settings to basically allow the ESCs to use their full range of input. You can see that these ESCs were written here. And we've changed the beep strength and beacon strength for the beacon setting, which means that as soon as the drone has been inactive for 2 minutes, it's going to beep at strength 47 for some amount of time. And that's useful because it will allow you to be able to have control of the drone, or to be able to hear the drone in grass, for example. So we'll go and disconnect, close this, open Betaflight again, go over to motors, understand the risks, and push the throttle up again. So now they should spin up almost immediately. And now somehow I've changed the wrong motors. Well, so we have an interesting problem here. So if I spin 1, it's actually spinning what's motor 2. And if I spin motor 2, it spins what's motor 1. So let's write these down. 1 spins 2, 2 spins 1. 3 spins 4, and 4 spins 3. So we're going to do what's called a motor resource remap to get these motors all in the right spot. So I'm not sure what happened when I was wiring it up, but I got it messed up somehow, and so now we're going to use this to change things around just because it's a good thing to know how to do. So if we go to Betaflight motor remapping, we get a bunch of different articles. My favorite is by Oscar Lang. And if you scroll down, basically, you can say, how do you change the motor output on flight controllers? So if we go into the CLI here, we type resource, and you get these settings here for motors. So you got resource motor 1, 2, 3, 4. Go back to our notepad, copy all this again, paste it, and delete each of these. Okay, so if we need to spin 2, currently it's being spun by 1. So 2, we're going to grab 1 and put it on 2. 1, so 2 spins 1. So if we need to spin motor 1, we're going to grab... Wait, let me mess that up. No, yeah. We're going to grab motor 2, swap it around. Then we know 4 and 3 are switched, so we're just going to copy paste each of those. Grab that, paste it, save, and now all of our motors should be in the right order. Motors, tick, throttle up a little bit. Sorry, not throttle up. We want to do 1. Now it's this one, and it's spinning the proper direction. Switch to 2. Now it's this one, still spinning in the wrong direction. 3, this one, still spinning in the wrong direction. And 4 is this one, also spinning in the wrong direction. So because we had that messed up when we did the BL Heli setting, we need to go back and redo it. So we need to... 1 was good, 2 is reversed, 3 is reversed, 4 is normal. Disconnect, go into Betaflight, connect, close, motors, understand, 1. No, wait, we already checked that, so we'll just do all 4. 1 is now in. So now 1 is backwards. Because... why? Because it didn't need to be reversed. Disconnect. Connect. Close. 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 Motors. Check. Up. 1's good. 3's good. 4's good. 2's good. Okay, perfect. So now we have our motors nailed. Sorry that was a little bit confusing, but I wanted to take you through some of the troubleshooting that you can do and some of the different kinds of settings that you can use. So, like, for example, we had a problem where our motor mapping was totally wrong, and we were able to solve it really quickly just by using some of the basic settings in Betaflight. We'll go over to the OSD tab. And there's a lot to look at here, but there's just a few basic settings that you want to have on here. One of them would be your battery average cell voltage. And just tick the 1 setting, and that's the actual voltage of the battery. Then I like to have my display name, not my display name, craft name, which is the name. So NERC budget, we'll just put that at the very bottom of the screen, kind of as a call sign. And then the other thing I like to put on is my timer 2 and VTX channel. So VTX channel just tells you which channel you're on, and then timer 2 is your fly time, which means the longer you've been in the air or you've been armed, that timer goes up, but it doesn't mean it doesn't be on when you just power it up. And then go into the font manager, click Betaflight or any of these fonts. I like the Betaflight font. Upload the font. It makes it a lot easier to read through the analog goggles. Close, go down to video transmitter. We're going to search for nameless RC VTX tables. VTX table. Just need to take this, copy it into CLI, Go to video transmitter. Now all of this is populated for us to be able to use with smart audio, which is great. Why is there a 600? Save. Disconnect. And now we're ready to set up our controller. Okay, so we're going to go into our model and page. So basically menu, page. The model name will be like, I don't know, drone. Next page. You just hit the page once. We don't need heli setup. We do need flight modes. We don't need flight modes. Now we're on inputs, and we need to set up 3 different switches. So to do that, we hit the source button, and then we flick the switch that we want. So this is our arm switch. So I like to use this switch here. See the SD. Exit, exit, go down. Hold to enter. Source on the second switch, which is going to be our angle horizon. This is a 3-position switch here, so we'll use that one. And then we'll go down one more. Hold down. Go to source, and then we need our turtle mode switch. I want to use this momentary switch, which is on the top shoulder, which lets go as soon as you let go. Okay. Now we have all those set up. So we go to the next page. And now we just need to, for some reason, this mixer page needs to have the same settings as the one before. And you can literally just click and hold in, and it automatically populates it with each of those. And that's it. So now we just need to bind this to the drone. Thank you so much for making it to the end of the video. We loved putting this together, especially once we got to go out and fly it. The budget build is by far surpassed our expectations, and I hope that you learned how to build the drone. If you have any questions about it, please feel free to use the comments below to ask questions. I'll periodically check it and try to answer anything that I might have left out of the video. So thanks very much for watching. Thanks for your support, your patronage, for supporting the channel in any way you can, and stay flying.